Hey friends, what's up? Welcome to my YouTube channel, Make the world of mechanical engineering contents. Today we are going to learn new topics of mechanical engineering materials. Let's get started.
So we were discussing about the fifth unit of mechanical engineering material, that is non-metallic and advanced material. In this chapter we are going to discuss today about the thermosetting plastics. So thermosetting plastics are those plastics which can resist the high temperature and which cannot be recycled. So in the thermosetting plastics we are going to discuss about the epoxides, which is also known as epoxy resins, then melamine, which is also known as amine formaldehyde or melamine formaldehyde or MF, and bakelite, which is also known as phenol formaldehyde or PF. Okay, about three different types of thermosetting plastics we are going to discuss in this lecture. So we will start from the epoxides or epoxy resins. These are obtained by condensation polymerization of epichlorohydrin and polyhydroxy compound. These are the chemical names or chemical compounds of which polymerization or condensation polymerization is carried out, and in result of this condensation polymerization we will get the epoxides or epoxy resins. Epoxy resins is cross-linked plastic by addition of a hardener. So we will perform or we will make the epoxides in two stages. In the first stage we will perform the condensation polymerization of epichlorohydrin and polyhydroxy. Then in the second stage we are going to add a hardener, okay, along with this epichlorohydrin and polyhydroxy to make the epoxides harder or to increase the hardness of the epoxy resins. If we talk about the properties of the epoxides, so these are transparent in nature, or we can add any color into this compound. Then this can be used as coating materials, as this compound possesses high toughness and high elasticity, as well as epoxides or epoxy resins have good chemical resistant. They do not react chemically with most of the uh, substances or chemicals. They are bad conductor of heat and electricity. Epoxides can sustain the temperature up to 300 degrees centigrades. Epoxides possesses the adhesiveness, the property of adhesiveness, adhesive and cohesive. These are the two different physical properties of the material, among which adhesiveness is called as the ability of a material or substance to stick with another material or substance. So epoxides possesses adhesiveness property in nature, so that this can be added in the adhesives or glues, where we can use these epoxides or epoxy resins in aircraft, in the automobile parts, in the insulating material or cables, and adhesives just like Fevicol, Fevikwik, as well as in the casting materials in domestic appliances. So these are the some applications about the epoxy resins or epoxides. Then second type of thermosetting plastic is melamine, which is also known as amine formaldehyde or melamine formaldehyde or MF. These plastics are obtained by condensation of urea or melamine with formaldehyde. So again condensation polymerization is going to happen. The compounds which are going to use to make melamine are melamine or urea. As all of you know that urea is a type of a fertilizer. So that same urea or melamine is used to make melamine or amine formaldehyde along with the formaldehyde. By condensation polymerization of urea or formaldehyde, we can get the melamine. So these are cross-linked polymers. They can be compounded with fillers, pigments and other additives to form molding materials of different colors. If we talk about the properties or characteristics of the melamine has more resistance to chemicals, heat and moisture. It is scratch free and more expensive. It has better electrical properties. It is highly affected by sunlight. Glass reinforced laminates have a heat resistance up to 200 degrees centigrade. If we talk about the applications of the melamine, glues for plywood, cellulose and foamed products, paints, surface coating, adhesives, plug switches, buttons, household uh, utensils such as cups and saucers, etc. So these are the some applications of melamine. Then third type of thermosetting plastic is bakelites, which is also known as phenol formaldehyde or PF. So phenol formaldehyde made by condensation polymerization of phenol and formaldehyde in an acid or alkaline medium. Asbestos, glass, fibers, pigments and other additives can be added to improve its properties. If we talk about the different characteristics and properties of the bakelites, so bakelites are available in black and brown color only, and as the components made by the bakelite compound loses its color or shining on aging, or if the component made by the bakelite comes in contact with the sunlight, then its shining and color will start to lose or it will discolors. As all of you have noticed that if you purchase a bike, then the shining of that bike is much higher, and as the time lapses or time goes on, then the shining of that bike will be degraded, or it will start losing its shining when the bike comes in contact with the sunlight. So same phenomenon is occurring with the bakelites. When bakelites, the product made by bakelites comes in contact with the sunlight, it gets discolored or its shining will get loose. It is strong and rigid in nature and dimensionally stable, so it can be used where heavy load going to apply on the components. So bakelights are preferred where heavy load applies on the component, as well as it is chemically inactive or inert with most of the solvents or solutions or chemicals. So bakelights can be used to make the containers or barrels to store petroleum products and several chemicals. Along with this property, bakelights can resist the high temperature. Bakelights have good dielectric characteristics and bakelights are cheap in the cost. If we talk about the applications of the bakelights, so bakelights are used in laboratory seats, thermal insulation or cellular foamed, paint and adhesives, vacuum cleaner parts, electrical parts, handles, knobs of or domestic appliances, impregnants of papers and formica. So as in the earlier lectures we had discussed about the handles of the pressure cooker and frying pans. So those handles are made by the bakelites. So I will show you an image in which we can see those types of products. So these are the different examples of the bakelights. In the you can see such kind of object on your spark plug cover, or such kind of part is also used as a spark plug cover of your two-wheeler. Likewise, such kind of handles you can see in your kitchen. So these handles are made by the bakelite material. Not only this, if you see a grinder, so in that grinder also you will find the bakelights. So these are the some examples of the bakelights. Come back to the topic. So here is a difference between thermoplastics and thermosetting plastics. So if we talk about the thermoplastics, these are formed by addition of polymerization, whereas thermosetting plastics are formed by condensation polymerization. Then if you talk about the thermoplastics are main long chain straight or slightly branched molecules, whereas thermosetting plastics are three-dimensional molecular structure. Thermoplastics are softened on application of heat with or without pressure, but they require cooling to set them to shape, whereas thermosetting plastics do not soften upon subsequent heating or cannot be recycled. If we talk about the thermoplastics can be molded, reshaped by subsequent heating and thus can be reused. So if we raise the temperature or if we heat the thermoplastics, then this can be brought to the semi-solid or semi-liquid stage and then can be reshaped or can be molded into any desired shape. In short, we can recycle the thermoplastics, whereas thermosetting plastics cannot be recycled. It will not get softened when temperature is provided to thermosetting plastics or heat is provided to thermosetting plastics. So in short, we cannot recycle the thermosetting plastics. Whereas if we talk about the thermoplastics, these are usually soft and ductile in nature, whereas thermosetting plastics are somewhat harder, tough and non-swelling as well as brittle in nature as compared with the thermoplastics. Thermosetting plastics can be recycled from waste, whereas thermosetting plastics cannot be recycled from waste. But research is going on. In the upcoming days, you can see that thermosetting plastics can also be recycled. Then come back to thermoplastics again. Thermoplastics are chemically soluble with some organic solvents, whereas thermosetting plastics are inert with some organic solvents. Then if we talk about the thermoplastics are used in plastic walls, floor tiles, light reflectors, plastic lenses, etc. Whereas thermosetting plastics can be used in mattresses, car parts, rollers, raincoats, gumboots, electric connections, etc. So this is all about your thermoplastics and thermosetting plastics. Third type of material which we are going to discuss in this chapter is rubbers. As earlier in the previous session we had gone through the same topic here, rubbers or elastomers. So we are going to discuss these rubbers or elastomers in detail. in this topic. So rubbers are highly elastic and resilient polymeric material. That's why it is named as rubber or elastomers. Rubbers or elastomers possesses the elasticity. It can be elongated 9 to 10 times larger than its original size. So rubbers are totally scientific material or artificial material or polymeric material which finds a wide application in various fields. They are organic polymers. Those are capable of being subjected to large elastic strain without plastic yielding. They can be elongated up to 10,000 or 1,000. Natural and synthetic rubbers are called elastomers. So right now in this chapter we are going to focus only synthetic rubbers or scientific rubbers or artificial rubbers. Natural rubber is a vegetable product which may be obtained from a variety of plants. It has excellent flexure characteristics. It is used in automobile tubes and tires, raincoats, floor mats, protective gloves, erasers, etc. Foam rubber is made by incorporating gas into latex and after that a process of vulcanization. Sponge rubber is produced from dry natural or synthetic rubber into which a bluing agent such as sodium bicarbonate and fatty acid are injected. Synthetic rubbers are materials with rubber like qualities but they are not as elastic as rubbers. There are many types of synthetic rubbers, namely methyl rubber, neoprene, Buna or Buna rubber, etc. So there are basically two different types of rubbers. First one is natural rubber, which is derived or which is obtained from vegetable products. So in most of the trees, if you have observed, we naturally collect the rubber from trees. I will try to show you how natural rubber is obtained. So from the trees, if you have observed, most of the trees produces the rubber which is collected in such manner, which is illustrated in this figure or in this photo. A collector is being used. There are certain or several kind of trees only which produces this natural rubber. Not all trees produces the rubber, natural rubber. Some of the trees produces the rubber. This is also called as latex or natural rubber. So likewise, if you see, most of the trees are cut in such a manner that if this tree secretes the latex, it is been collected through this passage only and in this container only. Look, the passage is created in such a way that with the help of gravitational force, the latex will be allowed to flow through this passage only. And then afterward, this rubber is processed and then been used in various applications. Not this original rubber is used or this original rubber do not have applications. After processing only, this rubber is been used in various applications. But the problem with the natural rubber is that it is available in the very limited quantity and which do not fulfill the requirements of the population. As the population is increasing so rapidly and we do not fulfill the requirement of the population with the natural resources, so that we have opted for the artificial rubber or man-made rubber, and then that rubber can be used to make various products such like this tires, etc. Then again, there are different types of rubbers. First we are going to discuss about the chloroprene or neoprene or CR. So neoprene is chemically and structurally similar to natural rubber, and its mechanical properties are also similar. It is resistant to oils, chemicals, sunlight, weathering, aging, and ozone is outstanding. It retains its properties as temperature up to 120 degrees centigrade and is one of the few elastomers that does not support combustion although it is consumed by fire. So these type of rubber or neoprene will not going to ignite or it do not catches fire even though it reaches the temperature up to 120 degrees centigrade. If you had observed that if we burns the tire, it produces the toxic gases such as carbon dioxide and carbon monoxide, which is responsible to deplete the ozone layer. In short, synthetic rubber is responsible to increase the hazardous gases such as carbon dioxide and carbon monoxide. Whereas chloroprene or neoprene do not catches the fire, so that there is no question of producing any kind of hazardous gases. Along with this property, neoprene has excellent resistance to permeability by gases. Although it is slightly inferior to natural rubber in most mechanical properties, neoprene has superior resistance to compression set, particularly at elevated temperatures. It can be used for low voltage insulation but is relatively low in dielectric strength. So neoprene finds some of the electrical applications as well, but neoprene cannot be used broadly in the electrical applications because of its dielectric strength. Its dielectric strength is somewhat low. So in the applications where voltage remains at lower level, just like your mobile charger, where voltage range is around 5 volts only. So in the similar kind of applications we can use this kind of rubber or neoprene. Now if we talk about the applications, so neoprene can be used in the conveyor belts. So what is conveyor belt? So this belt is called as conveyor belt. The black rectangular section or black rectangular component is called as conveyor belt. So such kind of belts you can observe on the railway stations and airports. Such kind of arrangement. You will also find such kind of conveyor belts in the stone crushers. Or metal segregation processes. So to make these belts we can use the neoprene. Okay, V-belts, hose conveyors, footwears, brake diaphragms, motor mounts, rolls and gaskets can also be made from neoprene. Okay, now what is V-belt? These are the images of V-belts. You will find these V-belts in your four-wheelers or heavy duty vehicles. passenger cars as well as heavy duty vehicles. You can find such kind of belts over there, which is used to connect the motor with cooling fan, which is mounted just in front of the radiator. Okay, so these belts are called as V belts. They have the V structure. In this image you can observe that the shape of this belt is like English alphabet V. That is why it is called as V belt. Okay, then footwears, shoes and chappals can also be made through neoprene, brake diaphragms, motor mounts, and rolls and gaskets. Again, we had already discussed about the gaskets in the last lecture. Now, what is motor mount? Let's see. Okay, this is nothing but your motor mount. The function of this motor mount is to reduce the noise and vibrations produced by the motor. So if here you can observe that this is nothing but your mount. माउंट करना किसे बोलते हैं हम लोग? माउंट करना किसे बोलेंगे? व्हाट इज माउंटिंग? माउंट करना मतलब लगाना, वहां पे जकड़े रखना, उसको पकड़ के रखना, ठीक है, होल्ड करना उसको, ठीक है। माउंट करना मतलब क्या करना, वहां पे लगाने के बाद उसको होल्ड करना। सो द फंक्शन ऑफ दिस माउंटिंग और द प्रोविजन ऑफ दिस माउंटिंग इज प्रोवाइडेड इन सच अ मैनर दैट इफ द मोटर विल start working, if the motor rotates, then obviously it is going to make some vibrations, and because of those vibrations it is going to produce the noise. So as to reduce the vibrations and the sound caused by that vibration, we use certain bushes just like this, which is made by the rubber material only, and specifically in the rubber, neoprene material is used to make these mounts so that we can reduce the vibrations. And as we reduces the vibrations, that means indirectly we are going to reduce the noise produced by that motor. Okay, then the next type of rubber is styrene butadiene rubber, or SBR, or it is also called as Buna S or GRS, styrene butadiene rubber. So if we talk about the styrene butadiene rubber's properties or characteristics, these are elastomers. These are copolymers of butadiene and styrene. Again, styrene butadiene rubber is a mixture of butadiene and styrene. Both of these compounds are mixed together to make a copolymer, just like we had studied about the alloys in the previous chapters. In case of metals, if we mixes two or more metals, that mixture is called as alloy. Likewise, in case of non-metallic material, and specifically in case of polymers, if we add two or more different types of rubbers together to make a mixture, then that mixture is called as copolymers. So here in this particular example, we are going to add butadiene and styrene together, and this mixture of copolymers is called as styrene butadiene rubber, or SBR, or Buna S. They are similar in many ways to the natural rubber. They are widely used because of their low cost. Wide range of property grades of these rubbers are produced only by varying the percentage of styrene and butadiene. They are non-oil resistant and are generally poor in chemical resistance. They have excellent impact and abrasion resistance. They are low in tensile strength, resilience, hysteresis, and natural rubber. They are low in tensile strength, resilience, hysteresis. What is hysteresis here? The term hysteresis came from the Electrical terminology, as you might have studied about the hysteresis current in BEE subject. So, styrene butadiene rubber possesses the low tensile strength, low resilience, and low hysteresis than natural rubbers. Okay. Now, what is the application of the styrene butadiene rubber or BUNAS? These rubbers are used in auto tires. So here you can see that to make such kind of tires we can use BUNAS. Okay, so BUNAS is a major constituent of these tires. Then third type of rubber is nitrile butadiene rubber or NBR or BUNAN. Nitrile elastomers are originally known as BUNAN. These are copolymers of acrylonitrile and butadiene. They are principally known for their outstanding resistance to oil and fuel at both normal and elevated temperature. Their properties can be changed by varying the ratio of acrylonitrile and butadiene. When the acrylonitrile content increases, then oil resistance, tensile strength and processability increases, while resilience, compression set, low temperature, flexibility and hysteresis characteristics decreases. Nitrile group are low in most mechanical properties. Their tensile strength is low because they do not crystallize appreciably when stretched. Resistance of this material is roughly one third to one half that of natural rubber. Their electrical insulation quality varies from fair to poor. If we talk about the applications of BUNAN, acrylonitrile grades are used where good flexibility at low temperature is of primary importance. Medium range type, which are the most widely used, find applications between these extremes. They are used for flexible couplings, printing blankets, rubber rollers, and washing machine parts. So, in short, we can summarize NBR or BUNAN as this type of rubber possesses very poor mechanical properties and they are used in very limited applications, or BUNAN finds very limited applications because of its properties, whereas BUNAN is a mixture of acrylonitrile and butadiene. Similarly, BUNAN cannot resist the high temperature and tensile strength of BUNAN is also quite low. So in short, BUNAN is harder in nature as compared with the other types of synthetic rubber. So this is the only reason because it finds very limited applications. Now after rubbers we are going to study about the silicones. Okay. So they belongs to the unique class of polymers which are not based on carbon element but on silicon. They have silicon, oxygen silicon backbone and are widely used in organic polymers. A variety of silicon polymers can be produced ranging from low viscous fluids of linear chain to rigid cross-linked chains. Silicones, also known as polysiloxanes, are polymers that includes any inert synthetic compound made up of repeating units of siloxanes, which is a chain of alternating silicon atoms and oxygen atoms combined with carbon, hydrogen, with some other elements. They are typically heat resistant and their liquid or rubber like. Most common are materials based on polydimethyl siloxane, which is derived by hydrolysis of dimethyl dichlorosilane. This dichloride reacts with the water. If we talk about the properties, low thermal conductivity, low chemical reactivity, low toxicity, thermal stability ranges from 100 degrees centigrade to 250 degrees centigrade, the ability to repel water and form watertight seals, do not stick to many substrates but adheres very well to other example glasses, does not support microbiological growth, good electrical properties. If we talk about the applications, silicones are used in sealants, adhesives, lubricants, medicines, cooking utensils, and thermal and electrical insulations. Some common forms include silicone oil, silicone grease, silicone rubber, silicone resin, and silicone caulk. So these are the different applications of silicones. So the material used to make these water bubbles is nothing but your silicones. Then come to the next topic, that is ceramics. We had already discussed a lot about the ceramics. Ceramics are brittle material and derived from the crushing of the stones. Ceramic is a non-metallic material or earthly material. First, what do we do to obtain ceramics? First, we will extract the stones directly from the earth crust. Then we will crush those stones into powders. Then we will make a clay by adding some adhesive elements in that powder so as to make the clay, and that clay can be molded into required shape to make the objects or components. Basically, nowadays we are using ceramics to make the tiles because ceramics gives very high surface finish, or it do not require any external operation to make the surface shiny and smooth. That is the only reason why ceramics are being widely used to make the tiles. And along with these properties, ceramics are capable to sustain heavy loads. I am talking about the gradual loads, not impact forces or impact load. So ceramics are very harder in nature. In fact, we can say that ceramics are brittle in nature. So because of its high hardness, it can resist the heavy loads. So because of this property, ceramics are used in making floor tiles, as well as ceramics can resist very high temperature. Because of this property, ceramics can be used in spark plugs, in two-wheeler as well as four-wheelers to make the spark plug. Spark plug is the component which is used to ignite the high pressurized air filled mixture. I will try to show you how spark plugs look like. So this is nothing but your spark plug, and this white color portion is nothing but your ceramic. So this portion get inserted into the piston cylinder mechanism or into the piston. Okay, likewise at this tip only it produces the spark, and this spark is used to ignite the high pressurized air filled mixture in the piston cylinder mechanism. Okay, and during this process the temperature of the cylinder is increased to hundreds of degrees centigrade. So if we, rather than using the ceramic material, if we use any other metal, then this metal may get damaged. So this is the only reason why we are using ceramics in the spark plugs. Next point is that rather than using the ceramics, if we use metals, then the metal will transmit these shocks or electricity to the car body or to the two-wheeler body, and which will result as a shock to the rider or to the driver. If we talk about the motorcycle, then it will give shock to the rider, and if we take example of four-wheeler, then it will give shock to the driver. So we want such kind of material who can resist the high temperature and who should not transmit the electric shock to the car body or two-wheeler body. So ceramic possesses both of these two properties. That is why ceramic is preferred for making spark plugs. Ceramic materials are defined are those containing phase that are compound of metallic and non-metallic elements. This is the processing of earthly material by heat. All early ceramic products were made from clay because they could be easily formed. It was then dried and fired to develop the permanent structure. Other forming methods used for ceramic material are injection molding, sintering, and hot pressing. All metal oxides, carbides, nitrides, borides, silicates are considered as ceramics. The common example includes glass, abrasives, refractories, cement, etc. If we talk about the properties of ceramics, they are hard, strong, and dense. They have high resistance to the action of chemicals to the weathering. They possess high compression strength compared with the tension. They offer excellent dielectric properties. They are good thermal insulators. They are resistant to high temperature creep. They have high fusion point below recrystallization temperature. No crystalline ceramics are fully brittle. Most of the ceramics are chemically inert. At high temperature, rigidity is high. If we talk about the applications of ceramics, they can be used for making tiles, sanitary wares, low and high voltage insulators, high frequency applications, heat resistant applications as pyrometers, burner tips, chemical industry as crucible jars, and components of chemical reactors, in refractory for industrial furnaces, in electrical and electronic industries as insulators, semiconductor, dielectrics, glass, porcelains, alumina, quartz, mica, etc. In internal combustion engines or IC engines and turbines as major armor plates in cutting tools. So these are the several examples of the ceramics. Apart from these examples, ceramics can also be used in various applications. So I'm just going to show you a short video how this sintering process is been carried out.
दूसरा जो है यहाँ पे एप्लीकेशंस टाइल्स के अंदर है, सैनिटरी वेयर्स के अंदर हैं। तो जैसा आप लोगों ने देखा होगा, आपका वॉश बेसिन जो होता है बाथरूम के अंदर, वो सिरेमिक्स से ही बनाया जाता है। टॉयलेट की सीट अगर आप लोगों ने देखी है तो वो भी सिरेमिक्स की मदद से बनाई जाती है। जो फ्लोर टाइल्स आपके रूम में लगे हुए हैं, जो ड्राइंग रूम में लगे हुए हैं, सिटिंग रूम में, लिविंग रूम में, बेडरूम में, किचन में, सारे के सारे जो फ्लोर टाइल्स हैं वो भी सिरेमिक्स की मदद से बनाए जाते हैं। उसी के साथ साथ जो वॉल टाइल्स हैं, जो बाथरूम में किचन के जो टेबल होता है उसके ऊपर वाले हिस्से में अगर आप लोगों ने देखे होंगे, या फिर जो है टॉयलेट और बाथरूम के वॉल्स के ऊपर देखे होंगे आप लोगों ने, या फिर जो है आपका जो ओपन स्पेस होता है फ्रंट, जिसको हम लोग वरांडा कहते हैं, वो वाले हिस्सों में अगर आप लोगों ने देखा होगा, या बालकनी वाले हिस्सों में अगर आपने देखा होगा, तो वहाँ पे वॉल टाइल्स लगाए जाते हैं। तो वो वॉल टाइल्स भी जो है सिरेमिक्स की मदद से ही बने होते हैं। उसी के साथ साथ इंसुलेटर्स बनाने में भी जो है सिरेमिक्स का इस्तेमाल होता है। अभी अगर आप लोगों ने देखा होगा, इस तरीके के जो है आपको
हाई टेंशन टायर्स के अंदर भी जो है आपको सिरेमिक्स देखने को मिलता है। इस तरीके से ये जो ब्लैक कलर के हिस्से नज़र आ रहे हैं आपको, ये भी सिरेमिक्स ही हैं। सिरेमिक्स को इसलिए यूज़ किया जा रहा है यहाँ पे क्योंकि ये दीज आर द बैड कंडक्टर्स ऑफ इलेक्ट्रिसिटी। तो इसमें से क्या होगा, इलेक्ट्रिसिटी पास नहीं होगी, तो इसलिए यहाँ पे सिरेमिक्स के ही ये कंपोनेंट्स इस्तेमाल किए जाते हैं। ओके, तो यहाँ पे एक एप्लीकेशन हो गया सिरेमिक्स का। उसी के साथ साथ और क्या हाँ है, हाई फ्रिक्वेंसी एप्लीकेशंस के अंदर इस्तेमाल किया जाता है। हीट रेजिस्टेंट एप्लीकेशन, पायरोमीटर, बर्नर टिप्स बनाने के लिए भी इसका इस्तेमाल किया जाता है। सो यहाँ पे मैं आपको बताता हूँ। देखो इस तरीके का क्ले तैयार करके सिरेमिक्स से और भी बहुत सारे जो है फ्लावर पॉट्स वगैरह बनाए जाते हैं, या जो है आर्टिकल्स तैयार किए जाते हैं, डेकोरेटिव आर्टिकल्स तैयार किए जा सकते हैं सिरेमिक्स की मदद से। इस तरीके के अगर आप लोगों ने देखा होगा डिज़ाइनफुल आर्टिकल्स, ये भी सिरेमिक्स की मदद से तैयार किए जाते हैं। सॉसर्स, कप्स वगैरह भी जो है सिरेमिक्स की मदद से तैयार किए जाते हैं। सो सिरेमिक्स फाइंड्स अ वेरी लार्ज एप्लीकेशन in day-to-day life, but we are going to talk about only इंजीनियरिंग एप्लीकेशंस। तो हमको ये सारी चीज़ों के ऊपर नहीं देखना है, ये सारी चीज़ें भी होती है, बनती है सिरेमिक्स से, बट हम किसकी कौन सी चीज़ों के या कौन से कंपोनेंट्स के बारे में पढ़ने जाने वाले हैं जो सिर्फ इंजीनियरिंग एप्लीकेशंस में इस्तेमाल होते हैं। तो इसमें से हमने एक एग्जांपल देखा डिटेल में सिरेमिक्स का देखा। देन दूसरा जो है इलेक्ट्रिकल हाई वोल्टेज वाले जो टावर्स होते हैं, ट्रांसमिशन टावर्स होते हैं इलेक्ट्रिसिटी के, उसके अंदर भी जो है इस्तेमाल होता है। देन बर्नर और बर्नर टिप्स के अंदर भी इस्तेमाल होता है इसके अंदर, और केमिकल इंडस्ट्रीज़ में भी इस्तेमाल होता है। क्रूशिबल जार्स और कंपोनेंट्स वगैरह बनाने में। अगर आप लोगों को पता होगा, जो अचार वगैरह बनाया जाता है उसको सिरेमिक के ही पॉट्स में रखा जाता है, क्योंकि वो ज़्यादा दिन तक ख़राब नहीं होता है। उसके अंदर रखा हुआ जो चीज़ है वो ज़्यादा दिन तक अच्छी रहती है, तो इसलिए जो है जार्स वगैरह बनाने में भी जो है सिरेमिक्स का इस्तेमाल होता है। उसी के साथ साथ फर्नेसेस वगैरह के अंदर भी, जहाँ पे बहुत हाई टेम्परेचर प्रोड्यूस हो जाता है और जहाँ पे मेटल्स का मेल्टिंग पॉइंट टेम्परेचर भी रीच हो जाता है, सो उन जगहों पर हम सिरेमिक्स का इस्तेमाल अच्छे से कर सकते हैं, और इसकी वजह से जो है सिरेमिक्स के लाइफ के ऊपर कोई अफेक्ट नहीं होता है। उसी के साथ साथ इलेक्ट्रिकल इलेक्ट्रॉनिक्स कंपोनेंट्स बनाने के अंदर भी होता है यहाँ पे, और आईसी इंजन्स के अंदर भी होता है, और कटिंग। अच्छा, और एक ख़ास बात क्या है इसकी सिरेमिक्स की, दिस आर वेरी हार्ड इन नेचर, और बिकॉज ऑफ दिस प्रॉपर्टी दिस मटेरियल और सिरेमिक्स कैन बी यूज्ड एज कटिंग टूल्स। कटर्स के तौर पे भी जो है इसको यूज़ किया जा सकता है। ओके So we will stop over here, and we'll continue in the next lecture. And in the next lecture, we will discuss about the glasses. Okay.
Thanks for watching the video. That's it for today. I will be back with new and interesting contents in the next video. Till then, take care and goodbye. Do not forget to hit subscribe button for getting notified when I will be back with new videos.